Okay, so continuing on with how do we figure out if a reaction is spontaneous or not? We learned how to create a table from these charts. And so from the practice exercise, we have this nice big table that shows us the strongest oxidizing agents going down to the weakest on one side, the strongest reducing agents going up to the weakest on the other. Pardon me. There's something that's called the spontaneity rule. And it's really pretty easy. It looks like this. It's two boxes, and if it's OA plus RA, then it's spontaneous. In other words, when you're looking at a reaction, if the OA is higher in the table than the RA, it's spontaneous. If the OA is lower in the table than the RA, then it's non-spontaneous. So I could say to you, copper sulfate is mixed with lead. Would this reaction be spontaneous? Copper sulfite would be Cu2 positive, it's the OA. Lead is Sb, it's the Ra. The OA is above the Ra, therefore it's spontaneous. But if it was beryllium mixed with lead, then the OA would be below the Ra and it would be non-spontaneous. So it didn't take us very long to realize, hey, creating a chart experimentally then can come in handy whenever we want to mix any combination of these, and we can figure out, okay, like these will be spontaneous, but these won't. And so we can begin to predict whether the reaction is spontaneous or not. So, like we said in the last video, one way to get the chart is experimentally like this. Another way is without having a table is if you have equations. So let's suppose we have three sets of equations, and I started writing this down while the video was uploading, and then I was distracted by something else and I didn't finish. So we have three equations, and from these three we're going to build another table. Going to CO2 positive aqueous plus Cu solid, and then Cu2 positive aqueous plus P, whoops, that's not a P, plus PD solid, going to no evidence of reaction. If it says no evidence of reaction, it means it's not spontaneous. So the idea here is you look at the first reaction, and if the products are written, then it's spontaneous, and you figure out which one's the OA and which one's the RA. So CO2 positive is going to CO solid. To go from 2 positive to 0, it must be gaining 2 electrons. If it's gaining electrons, it's reduction. And if it's being reduced, it means it's the oxidizing agent. Whereas the In is 0 going to 3 positive, which means it's losing electrons. And if it's losing electrons, it's oxidation. And if it's being oxidized, it's a reducing agent. Okay? So then you say, all right, this is spontaneous, which means the OA must go above the RA in the chart. So then we begin to build our chart, and so it will be CO2 positive aqueous plus 2 electrons going to CO solid. And the RA has to be below it, so it will be In solid has to go over here because this is where the RAs are. And on this side, it'll be 3 positive aqueous plus 3 electrons. Okay, so the RAs go on the RA side, the OAs go on the OA side, but the RA has to be below it. Notice I dropped the 2's. You wouldn't put 2 and 2. That wouldn't be reduced, right? So you always make sure that your equation is reduced as much as possible, the lowest numbers. Okay, so we have two things in our table. Now we look at the next equation, next reaction, and it's Cu2 positive going to Cu, which would be a 0. So the copper needs to gain 2 electrons. If it gains 2 electrons, it's being reduced, and if it's being reduced, it's the oxidizing agent. This one's going from 0 to 2 positive, although I can't really make out my writing, but it is 2 positive, which means it's losing electrons. If it's losing electrons, it's being oxidized, so it's the reducing agent. The products are written down, which means it's spontaneous, which means the Cu must go above the CO. And the table. So here's the CO. The Cu has to go above it, so this will be copper 2 plus aqueous plus 2 electrons going to Cu solid. Right? Cu is above the CO. Now we go to the next one. It doesn't show us what it would go to, but we know that if it did react, the Cu2 positive would become copper sulfate, and the PD would become 2 positive. Sorry, I was looking on the periodic table. PD 2 positive. Okay? It's so Cu2 positive going to Cu solid is being reduced because it's gaining electrons. If it's gaining electrons and being reduced, it must be the oxidizing agent. This one's going from a solid to 2 positive. It's being oxidized, which means it's the reducing agent. But this time, it's non-spontaneous, which means in the chart, the Ra has to go above the OA, which means the PD has to go above the Cu, which means it has to go on the top here. So it's our reducing agent, so it goes on this side. Over here will be PD2 positive aqueous plus 2 electrons going to that. And so we have our chart. This will be the SOA going down, and this will be the SRA going up. And our chart is done. Okay, so it's another way to create our charts. So today, I would like you to practice it with these guns. Okay, so you'll be creating 4 different charts. This time you don't have to put them together because they're not necessarily connected. Okay, but I'd like you to try these 4 for your practice today to see if you can get the 4 charts. And if you get stuck on one in the set, move to the other. Very good.